Hello and good morning. Today I would like to present the assignment 2 ICS Intelligent Control System Recyclable Material Classification by using Convolution Neural Network. First is introduction. Recycling is necessary for a sustainable society. The current recycling process requires recycling plant to absorb the garbage and use a series of large filters to separate more defined objects. Our motivation was to find an automatic way of sorting garbage. This the potential to make processing plant more efficient and reduce waste. As employees don't always sort everything 100%. To mimic a material flow in a recycling facility, or a consumer taking a picture of a material to identify it. Our classification problem is to get picture of a single object and classify it into a recycled material type. For the related word, project from the Teach Class Destruct Hackathon, which a team developed auto trash and automatically sorting trash can, which a Raspberry Pi power module and a camera between compost and recycling can distinguish. Another garbage-related project was a smartphone application that was used to roughly segment a garbage heap in an image. The goal of application is to enable citizens to track and report trash in their neighborhood. The data set used was retrieved via BIG image search, and the author extracted parts from the image to train their network. For the data collection, we used the provided PET bottle and aluminum can photo from the Google Drive, which were already in a training and validation folder. For our work, this is a small data set of 676 photos that has been divided down into two different shots of waste material such as bottle and aluminum can. For the methodology, this is the chart flow, how the system process. The CNN network convolution neural network model is the basis of several contemporary neural architecture. For supervised image categorizations, instead of generic metric multiplication, CNN consists of convolutionary layers where neurons are linked such that with a divide rather than connected. Special patterns are thereby created, which is invariant to conversion, revolution, and other alterations. In this figure, we explain about the proposed system. For the simulations, task 1. For the task 1 simulations, convolution neural network, we have to connect to the Google Drive, create CNN model to train data without overfitting and underfitting. Is employ prearranged data for training and validation. Select any acceptable number of convolutional layer fitting folding stripe, padding, and dense layer for this purpose. There can several steps that must be complete in order to run the software training validation. The first step is connect to Google Drive. The second step, fix data directory for Colette Netbook can access folder in the Google Drive. And the step 3, we have to create a train and validation data directory. For this step, it requires a path directory from the folder that has picture from the train and validation. For the can, train length is 156. For the pet, train length is 310. For the can validation length is 77. For the pet length is 133. And the length is 3. For the step 4 is we have to construct the CNN model. This result is about to generate a model that consists of layer, output shape, and parameter. The total parameter is 19034,177. Trainable parameter is 19034,177. Then and non-trainable parameter is 0. You can see the result at the below of the coding. And the step 3 is pre-process the input data. So for the next step is start training process. Step 6 will begin a training procedure which 24 steps per epoch, 10 epoch and 24 validation steps. It takes time to complete this stage in order to obtain a result for accuracy and loss. After completing this training procedure, we draw two graphs that indicate training accuracy versus validation accuracy and training loss vs validation loss. The validation accuracy is 0.9, the loss is 0.5438, and the accuracy is 100%. For the step 7 is training and validation accuracy and loss. Finally, to select the accuracy from 10 epochs in a graph, it refers to a greatest value of validation accuracy, as shown in a figure where a maximum training accuracy is 1 and the highest validation accuracy is 0.9 or 19%. So the first picture is pet and can stay from the distance from the camera. We get this image is 100% can and 100% pet. The second image is pet stay and can move further backward. We also get the image is 100% and can 100% pet. For discussion of task 1, according to the finding for task 1, it has enhanced accuracy, and picture 1 has outstanding accuracy as do as 2 and 3. This is because the image was trained with pet and can same frame. This illustrates that the system can recognize photo properly when given with a range of image. Furthermore, the convolution layer is an essential component of convolution neural network, which is composed of a stack of mathematical operations such as convolution, which is a type of linear operation. Image picture in digital image are recorded using a two-dimensional grid. I think that's all from me. Continue to Muhamad Idzat. Thank you.
Assalamualaikum and greetings, Dr. Rafidah. My name is Muhammad Izzat Fahmi bin Yusri as the second presenter from this group. And for my part, I will explain about the task 2, which is the assignment to select any two pre-trained model. But in our paper, we only use a single pre-trained model with a different layer of convolution, which is VGG16 and VGG19 model. As per shown on the screen, this is the platform used to achieve our objective of assignment. We use Google Collaboratory to do the programming. So for the very first step of the process is we need to connect the Collaboratory to our Google Drive. And then for the step 2 is we need to feed the dataset directory, which is from the Recyclabe folder. This Recyclabe folder can be obtained from the instruction paper from the lecturers. And then the step 3, the command is to create the training and validation data directory. So for the training directory, we have a can and bottle, and also validation also can and bottle in the recycle folder. So from this output, we obtain the can training length is 156 and bottle training length is 310, and also the can validation length is 77 and the pad validation length is 153 based on our recycle folder dataset. And step 4 is to construct the pre-trained model with a VGG16. From this output, we obtain the total parameter for the dataset, which is 80,910,017, and also trainable parameter is 4,195,329. And for the fifth step of the process is the pre-process of the data input. And this from this step, the VGG will recognize the images belonging. So 466 images belonging to 2 classes and 210 images belonging to 2 classes from validation and training directory. And for the step 6 is to start the training process. This is to generate the train generator and the step per epoch. And the step per epoch is the full cycle through the training data. So if the epoch numbers is larger, so it has a more full cycle for the training data. And the step 7 is to plot the outcome of our training and validation, accuracy and loss. And this is the output obtained from the dataset for a VGG16. For the task 2, the step to do the to generate the output for task 2 is mostly same from the VGG16 and VGG19. So we also go through the drive connection process, the dataset directory, and also the train and data directory. So as we can see from this, after the step 3 process, the bottle and can training and validation numbers is same as VGG16 because we are using the same dataset. So the main changes we add in the line of program is the input shape of the VGG, which is 150, 150 and 3, and also the matrix of accuracy. After the process, the output obtained will be different. The total parameter also different. We get 24,219,713, and the trainable parameter is same, 4,195,329. And also the pre-processed data input will give the same output as the VG16, which is 466 images belonging to 2 class and 210 images belonging to 2 class for the training and validation. And also for the VG19, we also did not change the step per epoch. We still use the 10 step per epoch for our training generator. And as the outcome, the training and validation accuracy shows the epoch, number epoch at the graph is equal to 10, and also the amplitude of the training and validation loss also increases at 2.5. And for the task 3, we have given image as shown in figure 1, and we need to investigate a suitable method that able to identify and count the recyclable material in the image. And for the discussion of the task 2 and 3, for the second method used in analyzing convolution neural network model is VGG. A pre-trained model is one that has been trained on a dataset before and has the weight and bias that reflect the characteristic of the dataset on which it was trained. The VGG16 and VGG19 has been applied with the step of epoch both set at 10, and this the difference between these two model is VGG19 has a 3 additional convolution layer, and this indicate that as the number of convolution layer increase, the performance and the accuracy both improve for the network. However, we need to understand that a number of epoch and the layer processing the data collected takes longer, and in addition, as the pre-trained model built a deeper network, it becomes vital to understand the extra layer may increase the difficulty and complexity of the network. And for the task 2, finally, the result obtained from the model shown the VGG both prove the model can accurately recognize the image, as it is a price-winning method proposed by a successor, K. Simonian and A. Zisserman. And to summarize, from the task 2 given, the additional layer in VGG19 can give the better result. And for the task 3, there was a lot of framework that can be implemented in CNN method in material classification for the image in the task given. It can be summarized by the suitable method is the design model proposed by the visual geometry group, which is VGG16 and VGG19 convolution neural network architecture. And in short, it is a prize-winning method in IISVR ImageNet competition in 2014. The background of the system is focusing in the convolution layers of 3x3 filter for the first strike, and second strike always have the same expo layer of 2x2 filter and padding. And the 16 and 19 refer to its number of convolutional layer in processing a dataset. So for a conclusion, the CNN is a nowadays topic that have a major role in image processing. This framework architecture also vital in the development of machine learning in the era of IoT, smart technology, and also artificial intelligence. Based from our assignment, we can see that task 1 and task 2 have been achieved. The created deep learning based recycling classification system to classify different materials such as bottle and aluminum can have been implemented. And then the method design is to classify the recyclable at a moment in time when polluting can be avoided. The accuracy of the CNN pre-trained model was 100% based on the result we obtained with the bottle and aluminum can dataset, and the accuracy of the VGG pre-trained model was also 100% based on the result we obtained with the bottle and aluminum can dataset also. And for result, we can assume that our system for classifying a recyclable material produced by a CNN and a VGG is smarter and faster with 100% accuracy. The accuracy of the result might be enhanced as our system add additional photograph to our dataset. And for the aim that by completing this project, we will be able to improve our system so that it can modify some of the parameters that will be used for additional types of recyclable material in the future, while also combining innovative technology from around the world. And that's all from me and my group. Thank you.